Hi everyone, thanks for having me. It's actually the first time that I'm delivering a talk in Portugal, so I can finally get to say Eduardo Bolsas and not Eduardo Lucas. That's good. So yeah, I'm gonna talk to you about different approaches to content and data management and data architecture on digital platforms. It's not going to be a very technical talk in the sense of showing lots of code and stuff happening. It's more of an overview of various approaches and methodologies I've used in my job to solve specific problems and overcome certain limitations, all the way down to where I'm currently at, which you can probably guess by the title of the talk, and guide you through what I've learned in the process, basically. So the first time I've ever used a CMS, I think it was in the early 2000s, which makes me feel a bit older than I'm comfortable with. But it was a platform called PHP Nuke, and it was this web application built in PHP that had a dashboard where you could instantly create and publish new content. Where multiple people could do that collaboratively, and they could do that without having to touch HTML files and push them over to a server using FTP, which is all I knew at the time. So to me, at the time, this was completely mind-blowing, right? It completely changed the way I approach web development. And it quickly became that concept of having a dashboard from where you can control everything. Quickly became part of my toolkit as a web developer. And even though PHP Nuke is not a thing anymore, thank God, the most popular CMS platforms that we have today still pretty much use the same core concepts. If we look at some of the numbers, have things like Drupal and Joomla and WordPress, and specifically WordPress, which has an incredible market share. So a quarter of every website published on the web is running WordPress, which is mental. And these platforms, they're very different from PHP Nuke. They're very different from each other. But again, the core concepts are pretty much the same. And I've used these platforms both personally and on professional on my job. For a long time, for a number of years. And one thing that I started thinking about is that these platforms kind of evolved into being something that is much more than a content management system. They've kind of evolved into being the backbone of entire web systems. To the point that, in my opinion, the name that we call these things, for example, WordPress, calling it content management system, I think it's a bit of an understatement. Because actually, in addition to being a content management system, these systems are also a digital asset management system, for example. Because when you're creating an article and you drag an image to the editor, something like WordPress will take care of uploading that asset for you, of storing it somewhere, of generating different versions of that image for you, different resolutions, different sizes, a thumbnail view. So it will manipulate that asset for you in any way you want. So they're also a digital asset management system. And the same can be said about users. So it's also a user management system because every type of actor that wishes to interact with your system, be it a site admin or an author or even a customer, they will be represented in the CMS. So it's also a bit like a CRM layer as well. So, and the list goes on all the way down to layout. With a typical CMS, you get to define how the final website will look, the structure of the page, color scheme, typography, anything. So we will control everything from this centralized dashboard. And at some point I started thinking, is this okay? Can this be a problem? Can the fact that you have this huge monolithic application controlling everything, is it a good idea? And to answer that question, it's worth having kind of a peek under the hood to understand how these systems actually work and how they're structured. And again, CMS systems are different from each other, but this diagram is a very simplified representation of how these things actually work. You have a data layer, a database where all the content is stored. You have a core application that is responsible to handle all communication to and from the database. And this core will then feed, on the one hand, the templates, which will render HTML to the end user, and on the other hand, an admin UI or a dashboard that site admins can use to manage the whole thing. And in the case of WordPress, for example, I'm going to use WordPress because it's the most popular one. From the three, the one I'm more familiar with. An example of WordPress, this would be a MySQL database, probably. Your core would be a PHP app. Your templates would be just WordPress themes, and the admin UI would be the dashboard that sits on this path. And straight away I see some problems with this monolithic approach. The first one being that when you're committing to using something like this, you're essentially committing to an entire tech stack, right? Because if you want to use WordPress, you're going to need to run a MySQL database and a PHP server, so you're effectively committing to a LAMP stack straight away. So you don't have the option in the future to, for example, represent your customers' data in a non-relational database, for example, which could be a problem. And also, you're also committing to all the features and the components that your CMS introduces. For example, if your CMS handles content publishing, users, and layout and assets, you might be really happy with the way it handles the content. But if you're not happy with how it handles users or layout, then you're in a bit of a problem. So you need to find a system that absolutely nails all the items that it implements, which can be a bit tricky. The other problem with this is, how can you easily integrate this with other systems? So if you have your content in a database, the way WordPress, for example, will get data from it is through the core app, which will use something like a native PHP MySQL driver to communicate with the database. But how do you do that if you have, for example, an Angular app? How do you, or any type of other system? How do you interact with that data? It's not reasonable to expect that any type of system that wishes to consume our data will have to connect to a MySQL database or any database for that matter. So how can we make that integration easier? And that, at some point in my job, I was working in a publishing company, and when I started there, it's a publishing company that has a lot of magazines, and they were using WordPress to manage all their content, their web content. But they also had a few native mobile applications. And they were using a completely separate CMS to publish content to those platforms, which from an editorial point of view, it's a nightmare. So having to publish the same piece of content multiple times just to cater to different platforms doesn't make any sense. And so at the time, what we did was we sort of transformed their WordPress setup into a headless CMS. And what this means, the headless CMS, is to try and decouple the layout part of the system from the rest of the monster. So the way we do this is we add an API layer that instead of exposing content and layout as HTML, as does the regular templating layer, it exposes just the content. And it does that in a format that other systems can easily interact with something like XML, but typically JSON. And so by doing this, we can plug our system into something like a native app or another web server running Ruby on Rails or .NET or whatever we want. And as far as the CMS is concerned, this is just another view, right? So this is just another view that does basically the same job as the templates view or the admin UI. It still communicates with the core. It still gets data from the database, but all it does is it exports the content in a format that other systems can understand. And this has some obvious benefits. Sorry. So the first one being separation of concerns. So by doing this, we can separate the content from layout, which makes sense from an engineering point of view. And this means that, as I said before, any front-end system can be plugged in. And because we've implemented it as a RESTful API, it means that any system that can issue an HTTP request can interact with our system. And because it uses a universal language like JSON, then everyone can take part. And the final benefit from this list, which is a very, very important one, is that we can now have a single publishing interface that can be used to publish content to multiple mediums, multiple devices, multiple platforms. And this item is the core principle of a philosophy called COPE, which stands for Create Once, Publish Everywhere. And the idea behind COPE, it aims to achieve a couple of things. The first one is, as I said before, separate data from design. It reduces editorial overhead, because now we don't have the madness of having multiple platforms to publish stuff to multiple mediums and devices. And it also means that our content is now reusable. So we create it once, we use it in every possible platform we can think of. And also, it's the most future-proof way that we can design our system, because we have no idea what sort of platforms we're gonna have to integrate with a year from now or a month from now. So the best way we can be prepared for that is to represent and deliver our content in a way that is agnostic of any tech stack, programming language, database engine, or implementation. But so this works really well. We've implemented the project. Everyone's happy. I believe they're still using it. I'm not at the company anymore. But at this point, I kind of had I was a bit skeptical. I wasn't too sure that this was, this didn't seem like the ideal COPE platform that would withstand the test of time and that I would want to use in every possible project in the future. So, sorry, one thing about that. And the reason for that was I found out, I could think of a couple of problems that this approach would have. The first one was that we still had a web CMS being the centerpiece of the whole system, right? We still had, even though from the outside world, we had a COPE platform that spoke in a universal language, at the core, our system was still a WordPress site, which is, as you know, a web application. And so it did seem odd that in the future we might have a project that had a very sort of a reduced presence on the web. If you think of Instagram, for example, you have the native app that is the core product, and then the web version has a reduced functionality. And that could be the case in one of our projects. Or we could even have a project that doesn't have a web presence at all. We could just have a project that implements a native application or multiple native applications, and it doesn't have a website. So if that's the case, does it still make sense to have a CMS that was built specifically for the web and to create websites? Does it still make sense to have that running the show? Another problem that this approach has is that our database, our core, and our API, and our admin UI are still very much tightly coupled together. Because, as I said, at its core, this is a about WordPress. So if we need to change the publishing interface, then we would have to basically rethink the entire system and do major refactoring, which doesn't seem very future-proof. And then finally, we've succeeded in creating a cope system, but it's sort of cope as an afterthought, because we took a product that was built for a specific need to create a website for a very specific paradigm many years ago, and we sort of applied this API layer on top of it. But it seems like it was sort of ducted together and like it's almost like a patch on top of what already existed. And I wonder if that's the most future-proof way of doing things. And so, I started looking around, reading a lot of stuff, seeing what other people were doing, and started putting together a list, sort of like a wish list of the features that I would love to have in a cope system. And this list, the first item on the list is I wanted my data architecture and my business logic to be agnostic of any tech stack. So if I'm going to build a project, I want to take the requirements from the stakeholders, and I want to take those requirements and I want to be able to represent all the data that I need to implement, all the validation rules, all the business logic, everything into a structure that doesn't make any compromise in terms of tech stack. I want to be able to represent that data as its own and then think about a tech stack later. I also wanted to have my features as modular and interchangeable components. So going back to the example I gave before, if I'm not happy with the way my CMS handles user authentication or publishing, or content publishing for that matter, I want to be able to just replace that component with another one, or be able to build my own component and plug it in with the rest of the system. And then I want it to be, obviously, I want it to speak an universal language so that it can integrate with any type of system. And then finally, I wanted it to be scalable on a micro level. And what this means is, if I have a system with this component that I mentioned before, and I'm building, for example, a product that will feed a website, iOS application, and an Android application from an API, I could probably use with scaling the API layer a lot more than just the web interface. Or, for example, if I'm building a video social network, I could probably benefit from scaling the digital asset delivery layer a lot more than maybe the API or the web server. So being able to scale things on the exact level that suits the nature of the project is a strong requirement. And this idea sounded a lot like microservices. And this is a really good definition by Martin Fowler, which is an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms, often an HTTP resource API. So this sounded exactly like sort of approach that would achieve the principles of code. And at this point, I started working with a company called Daddy. And what we did, we built a product. We built a data and content management platform. It's an API-first approach. So everything revolves around a RESTful API. All the features are implemented as modular, self-contained and deployable components. And the most important part of it is scope by design. So instead of taking a platform and figuring out how to achieve code with it, we took the principles of code and sort of built an entire tech stack around it. It's built in Node.js. It's scalable, and I'm going to talk to you a little bit about that in a second. And lastly, the small detail that separates this last section of my talk from an annoying sales pitch is that it's free and it's open source. So a quick overview of the core products of our platform. We have The platform is called DAD. By the way, we have DAD API, which is a RESTful API layer. It uses NoSQL. So at the moment we support MongoDB, but we're looking to integrate other data stores in the future, such as RethinkDB and others. So our content in API is stored as documents and grouped in collections. And the way you define a collection is by creating a JSON schema. So a file that represents your data structure, your field types, the field names, field types, any validation rules, any constraints. So at this point, you represent your entire business logic in a JSON file. So at this point, you're not committing to anything. Right? And by the way, it's fully REST API. So it means that your documents obviously can be edited using RESTful endpoints, but also the collection schemas themselves can be edited in endpoints. So you can create a user's collection, for example, that specifies name and age, but you can change the nature of that collection by pinging a certain endpoint. So everything is a RESTful API. We also have publish, which is a CMS in a more simplistic term. So it's an editing, it's a content creating interface. It connects to one or multiple instances of API to allow you to create and edit content. We have CDN, which is a asset manipulation delivery layer, which allows you to do really cool things like you can store like a huge raw image, and then you can using a URL, everything is the RESTful API again. Using a URL, you can request different variations of that image. You can request a thumbnail with the specific dimensions. You can manipulate that image, so you can specify that you want that image in black and white with a 30% blur and anything that you want, really. It has some cool features that I'll just briefly discuss at that time. And then we have our web layer called web, which can be plugged into that API to work as a full stack application, or it can work as a standalone Node.js server. So this is an example of how the stack could be put together. So we still have our data layer, our database, which will be accessed by the API layer, and then all these dashed arrows that you see here are just HTTP requests. These are just JSON schema flying around, so anyone can communicate with any of these components. In this case, for example, we have one instance of API feeding a web layer, in this case, Data Web. It's feeding CDN publish, which is the CMS, and it's feeding, for example, a native application. And you can see that anyone in the system can use digital assets from CDN. For example, Data Web is requesting assets from CDN, the same with publish, and the same with native application, because this is just an HTTP request that allows you to retrieve assets or create assets, so anyone can use them. And CDN can be connected to media storage. It can be a local disk or Amazon S3 or whatever you want. And this is like a real example of a project we built, and this is how we've layered our Lego bricks. Basically, we have our database. MongoDB allows you to have a sharded cluster. So in this case, we have two shards in the database that are feeding three instances of an API. One of the instances is feeding two native apps, one iOS, one Android. They're both sharing an instance of CDN for digital assets. We have another instance feeding the web layer, and another instance feeding the CMS, in this case that we publish. And we built an iOS app that actually works as a CMS because everything is modular component and everything speaks JSON and everything is a RESTful API. You can easily build any type of application that is effectively a CMS, which is what we did with this native iOS application. So this is a more complex real case example of how you can use the platform, and as you can see, how you can scale each of the components to better suit our needs. For example, in this case, we didn't have the need to scale the CMS a lot because it was used by a relatively small team. But we did have the need to scale the API as much as possible because it's basically feeding the whole thing. So these are just some numbers, nothing special, but just to show you that this is being used in production in large-scale websites. Sort of 100 million users a month. We've helped editorial teams of up to 400 people, which is quite impressive. And we have these concurrent users. So, as I mentioned, we have, it comes with a lot of benefits. The first one is scalability, as I just showed before, so you can scale each component of the system to better suit the needs of the project. And it also brings us developer liberation. And what that means is that because each feature is a modular component, you can have engineers focusing on a single area of expertise. You can have your front-end engineers working on the web layer without ever having to touch the API implementation or the CMS or caring about how those work. And it also means that it's fast to market. And what I mean by this, and I'm going to show you an example of what that product, of that project looked like when we built it. It means that the first part of any project is to define the data architecture, to define our API layer, and to define how data in our system is going to be represented and how it's going to relate to each other. But as soon as we do that, and as soon as we agree on a structure and a format for our API responses and for our error codes, for example, then everyone can get on with their work concurrently. So in this case, the first step of building a project was to define the API layer, define the schema. And then we had 4 teams working in parallel. So we had one team working on the native apps, another team working on the web layer, another team working on the CMS, both Daddy Publish and the native application, and another team setting up the CDN layer. So, and this is one of the elevator pitches sentences from the company, which I don't usually use, but it applies in this case. This allows us to get to market in days and weeks instead of weeks and months. We have a couple more products in the pipeline. We have Daddy Track, which is our data capturing layer. So it could do something similar to Google Analytics, but a bit more, we hope. We will have a platform called Data Visualize, which will be a visualization layer that can be used with Daddy Track or any type of data source. Daddy People, which will be our CRM layer that will handle everything concerning to users. So user authentication, authorization, permissions, identity, everything about users. And Daddy Machine, which will be a machine layer, a product that will understand data from the other components. And the interesting thing about all this is that, I don't know what the next part of this presentation would be, because it's, as you know, everything is evolving so fast that it's impossible to call a solution fully future-proof. But in my understanding and in my experience, having things as modular components and to abstract content from implementation is the best way that we can be prepared for whatever lies ahead. As I said before, thank you. As I said before, the platform is open source. It's free to use. You can check out I can post some links to the repositories where you can find all the information. We would love to chat with you if you build something with a platform. And yeah, feel free to hit with any questions. If I have some time, I can show you just a couple of the components real quick. If not, you can check them online. And